Hi, in this video I will be covering the sum and product rules for rational and irrational numbers. So when you log into Canvas and go down here to Tuesday under what do you do today, an important announcement is to know that there will be a quiz tomorrow, as in Wednesday, okay? So um, it will be on the material that we covered Friday, and then practice Monday and that you're learning today. So make sure you know it and know it well for tomorrow's quiz. It, like I said, will be on not just your product and sum rules for today, but classifying rational and irrational. Like how do you know which is which? It will be on Delta Math, and it will look like the Delta Math practice questions that you did on Friday, Monday, and Tuesday. So including today. So as long as you know that stuff, you'll be good to go. And you can go back in Delta Math and kind of click back over the problems and practice and make sure you understand them. So super important, guys, is to make sure that you are joining live for Zoom. And, of course, at second period, you have two options since we teach at second and fourth period. You can join at either 10:25 a.m. or at 1:40 p.m. I highly recommend that you do that for those students in Miss Allen and Miss Robinson's classes, okay? And here's the Zoom link. So, guys, important here is if you do the assignments with us on Zoom, then you're going to get all the notes that you need. You're going to show us the notes, like just show us over the camera. We're going to give you 100 for notes, and we're going to go through the Delta Math assignment together so that you'll be able to get 200s. If you are choosing to be asynchronous, meaning you're doing this on your own, then you're probably either a really good math student or you're probably not going to do as well. We highly, highly, highly recommend that you do this especially since the Board of Education just voted to for all school to be all virtual, meaning A and B week students will not be going to school for the next couple of weeks. So not until January 26th will A week students resume. But today, if you are asynchronous, then you will watch the video at the top of the Delta Math assignment, which is right here. And then you will take all the notes and then complete problems 1 through 12. I am going to do some of them with you in the notes. And then you will need to put the answers in Delta Math yourself. And then make sure that you are writing the practice problems down in your notebooks because you do get to use all your notes for your quizzes. So wouldn't it make sense to have the problems written down so that you can use them for your quiz? Just a thought. So those examples will help you out on the quiz, okay? And then you're just going to take a picture of the notes and submit them in Canvas. So I'm going to go ahead to Delta Math, and actually I'm going to, I'll just do it in this format. I'm going to go ahead now to my notebook and just do a quick recap of rational and irrational numbers for those of you that may be a little rusty. So as I'm using this terminology, it won't seem unfamiliar to you. So this comes from Friday's lesson on rational and irrational numbers. If you have not done that, you need to go back and do that. So just as a quick recap, rational numbers are all numbers that are natural, whole, and integers, along with all fractions. And remember the definition of rational, they can be written as a ratio, and irrational numbers cannot be written as a ratio. And remember, a ratio is just a fraction, okay? So other things to remember, they can be either positive or negative. Being positive or negative has no effect on whether it's rational or irrational. In terms of fractions, all fractions can be written in decimal form, like say even a natural number 5. We could write 5 as 5.0, could we not? That's a decimal. But that decimal terminates, meaning it stops, right? So remember that when converted to a decimal, rational numbers will always be decimals that terminate, or that repeat. Also important to remember is that if you have the square root of a perfect square, it will be rational. So for example, the square root of 25 is 5. The square root of 100 is 10. These are all things you should have practiced on Monday and should know very, very well. So to contrast that, irrational numbers cannot be written as a ratio. They are neither natural whole integers or fractions. They are either square roots of non-perfect squares. So again, a number like the square root of 5, the square root of 2, negative square root 3. If we can't take the square root of it in our heads, then as long as it's less than 225, then it's not a perfect square, and therefore it will be irrational. Why? Because as a decimal, they do two things. They are non-terminating. And how do we indicate that something is non-terminating? An example might be 4.312, and we can use ellipses to indicate that it goes on and on forever. So that's what it means to be non-terminating. And so they have to be both things, non-terminating and non-repeating. So if we take a look at this, 312, it's going on and on, but it is not repeating, okay? If it is a repeating decimal, like this, decimals that repeat, then it would be rational. So these are key things to remember: non-repeating, non-terminating, non-perfect square. So look at those three non-words, okay? Non-perfect square, or not a perfect square, non-terminating, or does not terminate, and non-repeating, as in it does not repeat, okay? All these three would qualify a number to be irrational, but that generally means all numbers with pi in it, such as maybe 7 pi or 3 pi over 2. One thing I do want to tell you about is the number 0 pi. If we think about what 0 pi is, 0 times pi is actually 0, which means this number is actually rational because it equals 0. Anything times 0 is 0. So keep that in mind. 0 pi is going to be rational, but any other number with pi in it is definitely going to be irrational. So just a quick recap of that information before we talk now about the product and sum rules of rational and irrational numbers. I apologize. This camera wants to be funky tonight. All right. So your product and sum rules. These are very important rules that we need to understand. We need to also remember that a sum means that we are adding two numbers, and a product means that we are multiplying two numbers. Okay, so these are going to be rules that apply to adding and multiplying rational and irrational numbers. So three rules that are always true. There's 6 rules total. 3 rules that are always true are that a rational number plus a rational number will always equal a rational number. So if we think about it like 5 is rational, if we add that to 1.5, we get 6.5. And that is a terminating decimal, so therefore it is rational, okay? Of course, that would apply for fractions as well. If I add 2/3 and say -2, and of course all these, by the way, we should be able to put in our calculator, and we should become pretty comfortable with it. So I'm going to go to my Calculate 84 app, which is my assumption that most students are using. Or if you've got a graphing calculator, wonderful. If you've got the Android and you install that Wabbit Emu app, awesome. So I'm going to here type in 2/3 plus -2. So 2/3 is 2 divided by 3. So we hit 2 divided by 3. Sorry, I'm trying to get it to where you can see it good in the video. Not going to work? There we go. 2/3 plus -2. Something super important to remember is that you always want to use this negative key to the left of the enter button. If you use the one above the add, that's always a minus. They are not the same. So if we are adding a -2, oh, I accidentally did a times. I didn't mean to do that. Then we're going to get this -1.3. So as we look at that, that's a repeating decimal. We can hit math and change it to a fraction by hitting enter, and we get -4/3. And remember, rational numbers are numbers that can be written as the ratio of two integers. So there we go, -4/3. That's a ratio. So that is equal to, I'll write this in 2 ways. 1.3 repeating, or negative 4/3, both of which are rational, okay? So adding two rational numbers will always result in a rational. If we are multiplying two rational numbers, this will also always result in a rational number. So just for instance, if I'm multiplying 2 times 6 is 12, clearly that's rational. If I multiply 2/3 times 1/5, remember when we multiply fractions, we multiply directly across. That would give us 2/15. Ratios of two integers are rational. So there's just a couple examples to prove to you why a rational times a rational is always rational. Now, what about when we add a rational plus an irrational number? So if I have a rational number, say I have the number 5 and I'm adding the square root of 2. 5 plus square root 2. How would I add those? Well, let's see what happens if we try to add it in our calculator. 5 plus, and if we do square root 2, remember we hit the blue second key, and then 1, 2, 3, 4 below the second key, we hit the x squared button to get our radical. So 5 square root 2. Again, that was, I pressed 5 plus, to get the square root, I hit second and then x squared, and then I typed in 2. And if I press enter, what do we notice? Wow, we get a long decimal, and there does not appear to be any type of repeating pattern. In fact, if I hit math, enter, and I try to convert this to a fraction, it will not convert it. And if we cannot make it a ratio of two integers, it is irrational. So we actually, this is an exact value. It's approximate value. I'm going to write these little tildes here. This is approximately 6.41421, and I'm just going to put ... I forgot the 1, didn't I? It just goes on, but there's not a repeating pattern. This is an exact answer, and you will in Delta Math have to enter them in like this. If I'm adding a rational plus an irrational, this is my exact value, and this is how I would type it in Delta Math. We can prove that it is irrational by looking at it as a decimal to show that it is non-terminating and non-repeating. So these three rules you have to remember, and it'll make it a lot easier. So remember, if it's irrational, it will not repeat and it will not terminate. So now let's take a look at our last three rules, which are more involving irrational numbers. Lots of I's, notice. So these are sometimes true, which means they're usually true rules, but there are a couple exceptions. So let's, for instance, look at this rule that says an irrational plus an irrational number is equal to an irrational number. Well, if I add the square root of 5 plus the square root of 3, both of those are irrational. Why? This is the square root of a non-perfect square, and I'm adding to it the square root of a non-perfect square. So remember, perfect squares are numbers we could take the square root of, like the square root of 81 is 9. We can't take the square root of 5 or the square root of 3 without getting an irrational number. In fact, if I just type in the square root of 5, try that again, square root of 5, then I get this non-terminating, non-repeating decimal, okay? So an irrational plus an irrational will equal an irrational number. In this case, it was approximately 2.236, but definitely did not have a pattern. Therefore, this is the exact value. If I said, what's the square root of 5 plus the square root of 3 exactly? You would say square root of 5 plus square root of 3. And that's how you would type it in Delta Math. But what might be some of the exceptions to that rule? Well, how in the world can I add two ugly numbers and get a pretty rational number? So let's put except when can I make an I plus an I equal an R? Well, we can do that if we were to have opposite irrational numbers. So if I were to ask you, if I give you the number 3, what's the opposite of 3? What do you think you would say? The opposite of 3. Well, the opposite of 3 is negative 3. So the opposite of a number like the square root of 2 would be negative square root of 2. So what happens when we add two opposites? As in, what happens when we combine 3 plus negative 3? So think about that. If I add 3 and negative 3, so I'll put negative 3 plus 3. We like that better. Negative 3 plus 3, we get 0. So when you add opposites, so adding opposites makes it equal 0. So I can put this negative square root 2 in parentheses if I want, but it's still going to come out to equal 0. And in fact, let's try that in our calculator. So I'm going to try to make it real clear. So if I type in, again, second x squared button, 2, and then I notice I hit the right arrow to come out of the radical. I'm going to just focus the camera, see if it focuses in on the calculator a little better. It does, good. So the square root of 2 plus negative square root of 2, notice I use the negative, not the minus for that, I get 0. Notice the parentheses aren't necessarily necessary in the calculator, but on paper we usually put them because it looks really weird to have plus and negative. But this is the same thing as saying negative square root 2 plus square root 2 also. So I'll say except when adding opposites. So that's our exception. So the rule is usually that an irrational number plus an irrational number will equal an irrational, except when they're opposites. Now that, of course, would apply for numbers with pi also. So if I add, say, negative 3 pi and positive 3 pi, because remember numbers with pi in it are irrational also, except for 0 pi, then that's going to give me 0 as well. And 0 is a rational number. It's rational, guys. 0 is rational. Why? It's a whole number. Whole numbers are rational. All right, so that's your exception to this rule here. Now let's look at an irrational plus a rational number. So an irrational number plus a rational number will equal a rational number. So for instance, if I have pi plus 6, what would that equal? Well, it is not 6 pi because 6 pi means 6 times pi. So if I were to type that in my calculator, let's see what happens. So recall that your pi key, I'm going to have to refocus again. Y'all be patient with me here. Trying to get the lighting right, plus make sure you can see it well on the calculator. So my pi button is located, if you look at the clear button, right below it there's an up arrow key. And there's a little blue pi symbol right there. It's real tiny, but it's right there. So to access pi, I have to hit the second button. It'll turn red on Calculate 84, and then the pi button, which is this up arrow. So there's my pi. And to pi, I am adding 6. And when I do that, ooh, I get a non-terminating, non-repeating decimal. So its approximate value is 9.14159, and I'm just going to put ... but that's non-terminating, non-repeating. So if I ask you what is pi plus 6, it's pi plus 6. This is the exact value, and this is an approximation, or it just means it's rounded. An approximation means a number has been rounded, okay? So an irrational plus an irrational is irrational with one exception. Guys, on number 5, I did change this up, by the way. I think I had a plus by accident here, so I rewrote it. So for number 5, the next rule is an irrational number times a rational number will equal a irrational number. Almost always. So again, as an example to prove this, an irrational, like maybe the square root of 2, times a rational, like 5. When we multiply a number that is under a radical with one that is not, it's kind of like multiplying x times 5 and we write it as 5x. We just put the rational number in front of the irrational. Okay, so that would be written as 5 square roots of 2. So this is almost always true, that an irrational times a rational will equal an irrational number. So when is the exception? So So let's come over here and write except when there's only, this is an easy one to remember, there's only one possible rational number, and it's when that rational number is equal to 0. So in other words, for example, if I have the square root of 8, the square root of 8 is an irrational number because it is not a perfect square, and I multiply that by a rational number 0, well, what's true? Anything times 0 equals 0. And again, it turns into a rational number. Similar to that, at the last one, it was adding to irrational numbers. So when we add to opposites, we get 0. When we multiply a number by 0, we get 0. So this is the only exception, okay? And irrational times irrational will equal an irrational unless when that rational number is equal to 0. All right? And then last rule, an irrational times irrational is irrational almost all the time. So for example, if I have, and this is important, so for the Delta Math assignment, you will have to multiply some radicals together. So if I have the square root of 15 times the square root of 2, well, what the heck would that equal? Well, I know if I try to type it in my calculator, if I type in irrational times an irrational, let's do square root 15. Oops. Wrong one. Square root of 15, and then again hit my right arrow to get out of the radical, and then hit times, not that. My fingers are not wanting to work very well on this calculator. Square root of 15 times the square root of 2. Then I'm going to get a non-repeating, non-terminating decimal. I cannot enter this number in Delta Math. I do need an exact value. So this tells me that we are going to get an irrational answer, but all you have to know is that when you are multiplying two numbers under a radical, you're allowed to multiply them together. So what is 15 times 2? Well, 15 times 2 is 30. So this would be our exact value, the square root of 30, and it is definitely irrational. So it's in the sometimes category for a reason. There are a few exceptions. So what I want you to note here is we are multiplying the square root of a non-perfect square times the square root of a non-perfect square, and the result in this case is a non-perfect square. So therefore, we know that the square root of non-perfect squares are irrational, and we just proved that in our calculator. In fact, if I do square root of 2 times the square root of 3, I'm going to get the square root of 6. Again, I can't take the square root of that. So therefore, it's irrational. So if it's in this sometimes category, that means there's some exceptions. So I'm going to come up here and put except when. So the question is, when will an I times an I equal an R? Well, that's going to occur when I do multiply two non-perfect squares, and my result is actually the square root of a perfect square. So let's think about that. Well, I'm going to give you the first example, so I'm going to put 1, and I'm going to take the square root of 10 and multiply that by the square root of 10. Well, we know that the square root of 10 is irrational because we can't take the square root of 10 and get an integer. But what happens when we multiply that together? The square root of 10 times the square root of 10, if you follow that rule that I just showed you, when we multiply two radicals, we can multiply their numbers under the radical together, and that gives us the square root of 100. Oh, well, what's the square root of 100? It's 10, and 10 is a rational number. So if we are finding numbers where we are finding products of like two numbers and the result is a perfect square, then we're going to get a rational number. I'm going to give you another example that also gives you 100, and I'm going to do the square root of, let's do the square root of 50 times the square root of 2. So these are not the same number, but when I multiply them together, I get the square root of 100, which again equals 10, and therefore is rational. Okay? So this is the exception. When I multiply the square root of a non-perfect square times the square root of a non-perfect square, and it results in the square root of a perfect square. So again, a quick recap. You have 3 rules that you need to learn where they're always. Can we use our calculator? Yes, but it is shorter if you grasp onto the concept here. So your 3, look at all the ones that are always true. There's only one that involves I. Only one. Look at all that. Rational plus rational is rational. Irrational times rational is rational. Irrational plus an irrational is irrational. And we just proved over here why. Okay? And then we have 3 other rules that are sometimes true with some exceptions. So again, as a quick recap, let me focus that. Sorry. If I add to irrational, I'll get an irrational except when opposites. So if I were like trying to do some keywords, so I would do da-da-da except when adding opposites. That's really the key information. This is true except when my rational number is 0. And lastly, an irrational times an irrational is irrational except when a non-perfect square times a non-perfect square results in the square root of a perfect square. If I said that right, the square root of a non-perfect square times the square root of a non-perfect square results in the square root of a perfect square. But of course, can you type this in your calculator and see if it goes on and it doesn't terminate and doesn't repeat? Sure. Can you type that in your calculator and see if you get a pretty number so you know it's rational? Sure. So that's going to conclude our notes. Make sure you take a picture of that. I am going to do a second video where I work through the Delta Math problems, like a few of them to help you out. So make sure you also get that in your notes.